lecture 22, we're going to look at one last group of trigonometric identities. One's called the product to sum formulas and the sum to product formulas. So what we basically will do is take a product of either sine and cosine, or sine in itself or cosine in itself, and turn it into the sum of two sines and or cosines. So in order to do that, I'm going to first just begin by writing down the formulas, and we're going to look at where these things come from right after that. So the sine of an angle times the sine of a different angle can always be written as the sum of, actually it's the difference of two cosines. It's actually going to be 1/2 times cosine of alpha minus beta minus cosine of alpha plus beta. The product of two cosines, that is cosine of alpha times cosine of beta, is always the same thing as cosine, or 1/2 cosine of alpha minus beta plus cosine of alpha plus beta. And then lastly, sine of an angle times cosine of an angle is equal to 1/2 of sine of alpha plus beta plus sine of alpha minus beta. To see where these formulas come from, you just basically take a look at a creative combination of the sum and the difference formulas that we learned in the previous lecture, and that basically falls right out. So consider the fact that if I write down cosine of alpha minus beta, we remember that this is cosine of alpha cosine of beta plus sine of alpha sine of beta. Similarly, cosine of alpha plus beta is cosine of alpha cosine of beta minus sine alpha sine beta. If I were to subtract, say, one equation from the other, take the first equation and subtract the next one. So the left-hand side becomes cosine of alpha minus beta minus cosine of alpha plus beta. On the right-hand side, if you're subtracting, remember, you're applying a minus sign to all three terms. Cosine of alpha minus cosine of beta, cosine alpha cosine beta minus cosine alpha cosine beta cancels out. If you take sine alpha sine beta minus a minus, you actually get 2 sine alpha sine beta. And moving the 1/2 to the other side, you end up with something that looks like, and I'm switching sides here, sine of alpha sine of beta is 1/2 of cosine of alpha minus beta minus cosine of alpha plus beta, which is exactly what one of our formulas looks like. And the other two fall out exactly the same way. But what this does is it recognizes that in the sum formulas and the difference formulas, you've got these products. And if you combine two of the sum formulas, you can cancel out one of those products and end up with just a single product, like sine alpha sine beta equals a combination of two trig functions just added together. So we're turning a product into a sum. Now let's look at a couple of these in action. So we are asked to express the following products as a sum, which contains only sines or cosines. So for this one, we recall that if I had sine of alpha sine of beta from the previous page, that's going to be 1/2 of the cosine of alpha minus beta minus cosine of alpha plus beta. So to apply this, I simply recognize that my 4 theta is going to be my alpha and my 2 theta is going to be my beta. So this becomes 1/2. That's 1/2 of cosine of 4 theta minus 2 theta minus cosine of 4 theta plus 2 theta, which we can then simplify to be 1/2 of cosine of 2 theta minus 1/2 of cosine of 6 theta. For this one, we recall that sine of alpha cosine of beta is 1/2 of sine of alpha plus beta plus, actually minus, sorry, is it plus? Minus. Plus sine of alpha minus beta. Okay, so that gives us, if 4 theta is, again, alpha, and this time 6 theta is beta, we'll have this is equal to 1/2 sine of 4 theta plus 6 theta plus sine of 4 theta minus 6 theta, which equals 1/2 sine of 10 theta plus 1/2 sine of negative 2 theta. And remember, with sines, you can pull the minus sign out front. So this would be 1/2 sine of 10 theta. Oop, not 1 theta. 10 theta minus 1/2 of sine of 2 theta. Let me do one last example, this time involving some fractions, but the truth is it's actually the same process, because we recognize that cosine times cosine of two different angles can turn into a cosine of alpha minus beta plus a cosine of alpha plus beta. So I'm just going to go ahead and go straight to the formula here. 1/2 cosine of alpha minus beta, so 3 theta over 2 minus theta over 2, minus, actually it's a plus cosine, I'm using the formula from the previous page, plus cosine of alpha plus beta, so this is going to be 3 theta over 2 plus theta over 2. This gives me a 1/2 of cosine of 3 theta over 2 minus theta over 2 is 2 theta over 2, which is just theta. Plus, this is going to be cosine of 4 theta over 2, which is cosine of just 2 theta, right? Again, this is 2 theta over 2. This is 4 theta over 2, which is where I get my theta and my 2 theta below. Or 1/2 cosine theta plus 1/2 cosine of 2 theta. Now, you may wonder, what is the good of being able to do this? Because it actually looks like it's a little bit more complicated when you have multiple terms on one side, so you got a sum. But the truth is, it actually relates back to something that we will cover much later on. The real, actually not even in this class, what this mathematics that we're learning in this class would be used for in later classes would be in calculus. In particular, when you're doing integration, in calculus, you will learn that integrating products of functions is much more complicated than integrating sums of functions. So if you can convert a product to a sum, you are going to have a great advantage to be able to do those types of problems in that class. But we're not covering integration, so we're just going to learn the skill here. And for those of you that may go on to take a calculus course, you would then recognize that you could apply this in those circumstances. Now, if we can go from products to sums, it just takes a little bit of creativity to go back the other way. If we have the sum of two functions and we want to come up with a product that represents that same function to be identically the same, you basically creatively choose what would be in the product so that you get the answer you want in the sum. But let me write down the formulas first, and then I'll show you kind of that reverse engineering step to make sure that you understand where it comes from. What happens here is that the sine of alpha plus sine of beta is equal to 2 sine of alpha plus beta over 2 times cosine of alpha minus beta over 2. Sine of alpha minus sine of beta will always be 2 sine of alpha minus beta over 2 cosine of alpha plus beta over 2. Cosine of alpha plus cosine of beta is 2 cosine of alpha plus beta over 2 cosine of alpha minus beta over 2. And the last one is negative 2 sine of alpha plus beta over 2 sine of alpha minus beta over 2. Okay, now if you didn't keep up with that while I was recording the video, you probably have figured this out long before now, but you can pause and try to catch up what I've just written. But those formulas right there are formulas that I'm not going to have you memorize for any test in this course, but are useful once you look them up to be able to convert sums to products. Now, to consider a proof for this is really basically pretty simple. Just think of sine, the first one. We'll only look at the first one. Sine of alpha plus sine of beta. The claim is that that's the same thing as 2 sine of alpha plus beta over 2 and cosine of alpha minus beta over 2. Now, we actually have a formula for converting this to a sum based on, this whole thing being, I'll put it in quotes, the alpha, and this whole thing right here being the beta. So if you start with the left-hand side, 2 sine of alpha plus beta over 2 cosine of alpha minus beta over 2. And recall that this was the same thing as, and again, I'm scrolling back up to the next page, from this formula right here, if you have a sine times a cosine, you can use that formula right there. 1/2 of the sine of the sum of the angles plus sine of the difference of the angles. So here, I'm going to take 1/2, and of course we still got the 2 out front, so I'm going to leave that out there. Now you're going to take the sine of the sum, so sine of alpha plus beta over 2 plus alpha minus beta over 2, plus the difference, sine of alpha plus beta over 2 minus alpha minus beta over 2. So the first, of course, the 2 and the 1 just become a 1. Now if you add these two things up, the betas cancel, and you're left with 2 alpha over 2, which is just sine of alpha. Plus, now if you distribute this minus sign, the alphas cancel, and you're left with beta plus beta, which gives me 2 beta over 2, which is, of course, sine of beta. And there's the plus sign in between, which is exactly what you're trying to prove. Voila, you end up with sine of alpha plus sine of beta. All you did here was you creatively chose these two angles right here, this one and this one, so that when you add them together, you get alpha, and when you subtract them together, you get beta. That's what alpha plus beta over 2 and alpha minus beta over 2 do, is if you add them together, you get alpha. If you subtract them, you get beta. So that's how you would convert then from a sum to a product. You just got to remember one of these, or look up one of these formulas. All right, 2 examples. So to change a sine plus a sine, so if this was alpha here and this was beta, remember sine of alpha plus beta, sine of alpha plus sine of beta from the previous slide is 2 sine of alpha plus beta over 2 cosine of alpha minus beta over 2. So in our case, alpha is 4 theta, so we have 2 sine of 4 theta plus 2 theta over 2 cosine of 4 theta minus 2 theta over 2. Which becomes 2 sine of 6 theta over 2, which is 3 theta. And 2 theta over 2, which is theta. Done. That's all there is to it. Similarly, if you have cosine of alpha minus cosine of beta, this is a negative 2 sine of alpha plus beta over 2 sine of alpha minus beta over 2. Which becomes negative 2 sine of 5 theta plus 3 theta over 2 sine of 5 theta minus 3 theta over 2, which is a negative 2 sine of, that's 8 theta over 2, so 4 theta, sine of, that's that's positive 2 theta over 2, so theta. That's what it simplifies to. And that's how we use the product to sum and the sum to product formulas.